the test, the student point.
I don't know. I haven't even looked at it. I forgot to transfer, so I've got to do that. So I will before 3 o'clock today. Okay. All right. So we're going to do chapters 7 through 13 before about May 20th, 23rd, something like that. So we need to stay up. Now, again, you can use the 3x5 cards. You can make stuff. Please, if you're not understanding, come in. I'm usually here after school. You just got to come in and get help. Okay? I'm going to be going to school too, down at SLIC to work on my biotechnology. So there'll be one day a week when I'm not here. Okay, I'll try and put that up on the board so you know which day. This next week is the day that the ACT is. So I'm trying to pick days that I don't affect people very much. Okay? So, but yesterday I spent a lot of hours in lab. Because that's what I'm doing is lab work. So be aware. If you're a junior, this is a really awesome program next year. I'm going to plug it again. Biotechnology. That's what I'm doing down at SLIC right now. You have to just take one class here. You get a job shadow, 2 companies for 4 hours each. At the end of that, you're guaranteed an interview with one of the companies. If both of them like you, they both might want to have an interview with you. After that, you start anywhere between $20 and $25 an hour, and they pay for college. So awesome opportunity. If you are a junior this year, going to be a senior next year. It's only for seniors. Okay? Yes. What? And they told us they were coming over. So if they know who you are and you've got the job, you can take, you say, I'm going on a mission, blah, blah, blah. Can I work for you for a little bit? Or whatever. You have to work it out with them. Okay, any questions? All right, I'm really pushing that because that is an awesome opportunity. You get college credit through UVU, 3 credits. You get a CTE certification, and you get a letter and a dinner from the governor, which is awesome because it's a medical organization's house. All right, having said that, we're going into gases, liquids, and solids. This is one of my most favorite units. I really like it because it really makes sense. So the first part up here is just a little thing where we're going to stop and talk about something that's actually happened in our community that happened a little while ago. That had to do with gases. Phosphine gas actually killed 2 young children in this neighborhood. Oh. Okay. Could this be have been avoided? I want you to look at that. And has anything like this happened before? Okay. So what you've got there on your paper looks like this. Okay. What I want you to do is I want you to Google search. It was up on KSL, it was up on ABC, it was up on a lot of the news channels. You're looking for hemotoxin kills children, okay, or something like that. I want you to research, find out what you can find out, and answer those questions that are on your paper. I'm going to give you 10 minutes. I want you to work as a group and figure it out. Yes.
And I did them first yeah. So those ones also these. Yeah, and then on this, everyone has a 0 on. It's because you guys have been to ask to take
Okay, work on that. I'll work on transferring your tasks while you're doing that.
She said our community. She said community. Literally says community. Our neighborhood. She's like back. It says community. Specific pesticides?
What?
Specific? I thought it was just like a combination of okay, so here's declared safe. Right, so children did
Are we looking for the one in Layton or
Yep.
Texas?
Layton, our community.
Texas, our community? Are we Texas?
Found it.
Boston is colors, flammable, and toxic gas with order of scarlet particles. It can ignite contact with air.
Exactly. What can that?
Haley, Haley's right here. Excellent.
I have no idea. You'll have to go to Phoenix and put it in and see.
And if it doesn't, then anything else can get
Reading labs and putting it in.
So it says 10 to 20 pots are recommended per barrel for the critters we're trying to get rid of for it. And then that's supposed to be placed within 15 feet for the residents. So it should have to put 15 feet there away from their house, which obviously that wasn't the case either. And then 10 to 20 pellets per burrow. And the invoice states that there was 907 in the back filled front area. So like
Okay, about 2 more minutes. Let's see what we can find and then come back and talk about it.
So there's even 5 pellets is immediate. Once mixed with water is immediately dangerous to life or health.
What does it do? Should I just say pesticide?
But what does it do? How does it work?
It kills you
How?
by turning water into an acid inside the
Okay.
lungs.
Okay. Be a little bit more specific.
This was told her something entirely different cat. And it wasn't a problem when she had to smell what it was, what the smell when she smelled it. Because it was an entirely different cat and it wasn't. I should be doing. ask about it and see and decide whether we figure what's going on. So and then pass. Everyone but mom got sick. That was confusing. I was just gonna say for like chapter 3, like because I was one of the 4 people that didn't have my chapter 3 like automatically fill it.
Last minute, finish up, get information from your friends if you need to. Okay, I think I've got everything fixed on your. Put it in. All right. So let's talk about this for a minute. What did you find out about hemotoxin? What is it? Pesticide.
Colored water
Okay. All right. It's a triphosphate, or yeah. Okay. What else? What else did you learn about hemotoxin? Yes.
Doesn't it like produce carbon monoxide? I read that.
It can as a side note, but what's the really important thing? Go ahead.
I just put it releases a gas when contact with water.
Okay, so what gas does it release?
Phosphine.
Phosphine. Phosphine gas is PH3. So that's what phosphine gas is. Okay, what about this next part? What is phosphine gas and what does it do? So it's PH3. When we breathe it in, what does it do?
Doesn't it like remove the oxygen from your lungs?
Oh, damn.
Okay, it smothers. What else? Okay.
It breaks down with the moisture in the lungs and in the air, and it creates a substance, I believe it's called phosphorus pentoxide or something,
Okay.
that is a severely toxic chemical that will attack the respiratory tract from your cardiovascular system and respiratory system.
So it's a neurotoxin. It basically is a toxin that attacks every system you have. It's a neurotoxin. Okay, so why the two youngest and not the older children and parents? Why did they die? Okay,
They have less immune system.
okay, less immune system, that could have contributed to it. What else? How old were these kids?
3 and
2 and
0.
15 months, about, yeah.
Their bodies were less smaller and weaker, so it took less time for the metabolism to spread.
Okay, their bodies are smaller and weaker. I'm thinking even, think about the kids that you know that are 2 and 3.
They really
They play in the
themselves.
They play what?
Play in the grass.
Okay, but it was wintertime.
They put things in their mouth.
They play on the floor, right? How often do adults play on the floor?
Not much.
Okay, what do we know about phosphine gas? It's heavier than air. So where is most of the concentration of phosphine gas? On the ground. Where the baby and the 2-year-old are playing. Okay, so why not the older kids? Because they were up here out of this fog. It's sort of like a fog on the floor. That's where it was. Okay? Alright. Why was it put in the yard?
Kill voles.
To kill voles. Anybody know what a vole is?
It's like a mouse.
A little bit bigger than a mouse, yeah. How was okay, so it was put in the yard. How was it cleaned up?
They put a bunch of, they flooded the yard, right?
They did. They flooded the yard and then they got big fans and blew it away. Because in small amounts, it's not toxic to us, but in large amounts it is.
Wait, so why did they flood it and then blow it away if it's...
Because if they didn't flood it, then it could react at any time. So they flooded the yard so it would react while they had the fans blowing to disperse it.
Oh, okay.
Okay, what was the problem here? Human toxins been used before to kill voles and haven't had a problem.
They had it too close to the house. For one.
They had it too close to the house, and guess what? Foundations do have cracks. Okay, so it came in through the foundation and
That and they put like 907 pellets.
yeah, way too much. But the guy wasn't trained. Okay, so there's a lot of things. This litigation is still going on. This
Wait, this
litigation
was
is still
10
going on.
years ago though.
It's still going on.
What's the normal use of those pellets? Like, what's the normal
Smaller amount, the smaller the better.
So it'd be like 200?
Yeah, and away from at least 20. Okay, so let's go on. This is what we're going to be talking about. Why is it important that you know about gases and how they work and the laws that are with them? We need to be able to see how things are going to happen in our lives. If this parent had known a little bit more about fumitoxin, do you think they would have allowed it to be put in their yard?
Not that close to the house.
Not that close to the house at least. So just a Google search of fumitoxin, you guys did it. How long did it take? To find out anything about it, right? So if before I have anybody put anything in my house or around it, I do a quick Google search. You got a phone on you all the time. Google search it. If they're going to come and spray for insects, what are you using? I Google search it. Because I got grandkids at my house. I don't want them down hitting the baseboard and then putting it in the mouth. Okay, so it's really important that as a consumer you research what is going on around you. It's important. Okay. What two elements are on the periodic table that are liquid at room temperature? You need to know these.
Isn't that
Mercury and
Rhodium.
it's number 3, right?
oh,
Bromine? Sorry,
bromine.
number 4.
Yes. Okay, I had you color those on your periodic table. They should be noted as liquids. What elements are gases at room temperature? There's more of them. Hydrogen, helium, oxygen, nitrogen. Okay, so hydrogen, if you bring hydrogen over to this side over here and slide it right next to helium, it goes nitrogen, oxygen, fluorine, chlorine, and the noble gases. Those are my gases. Okay, so it's an upside down L and then the noble gases. What is the most common state that elements are found in? Solids. Yeah, that's easy. Okay, so bromine is a liquid, has a lot of issues that can go on if you breathe it in. A lot of times bromine is used in hot tubs to keep stuff under control. So you have to be careful, okay? It hangs on in pairs. Mercury is the other one, okay? That's a liquid. So if we're looking at two liquids here and the gases, most of the rest are solids, okay? Fairly easy to remember. So if I write down what's a liquid and what's a gas, really easy to say what's solid. Okay, what's the difference in physical properties? This chapter to me is sort of like a duh. We've had this since elementary school. So, density. When we're talking about density, high, a high density would be 110 grams per milliliter. That would be a high density. Okay, high in a liquid would be about 1 gram per milliliter. So if I get more than 1 gram per milliliter, I'm going into a solid. So what do you think about a gas?
Less than that?
0.01. Okay, less than 0.01 grams per milliliter. Next thing we want to talk about is shape and volume. This is pretty easy. What about a solid? What shape does a solid take? Definite shape, definite volume. Liquids are indefinite shape because I put them in whatever and they take the shape of whatever I put them in. What about gases?
They have no shape.
They have indefinite shape and indefinite volume. Okay, next property we're going to talk about is compressibility. Compressibility is how I can squeeze it down. Solid, I can squeeze some solids a little bit, but it's not going to show. Liquids, small. If not, my brakes wouldn't work, right? Those of you who know anything about cars, we have brake fluid in there. There's no such thing as blinker fluid, though. Okay? Okay.
Headlight fluid.
Yeah, don't do it. Okay? The arrangements of particles. Solids are fixed. Liquids are randomly arranged and they sort of fall over each other, very close. And gases are extremely disorganized and they're very, very far apart. Okay? When you look at the particle movement, in a solid, it's more like a vibration. I know it says slow here, but it's more like a vibration. So if you want to put a little thing that says vibration there, great. In a liquid, we've got moderate movement. It sort of tumbles over each other in the molecules. And then in the gas, they're very, very fast and they're far apart and they're zinging and zinging and zinging. Because this particle movement is slow and they're really close together, the interactions between a solid are strong. Very strong. In a liquid where they're tumbling over each other, they're moving a little bit more, so the interactions are not quite as strong as if they were standing still and sort of vibrating. So it's sort of like in the halls, when people are moving, they're moving, and we've got the liquid flow going, but when people stop and start talking to each other and everybody stops around them, we get a clog, right? Okay? And then gases don't have interactions because they're far apart and they're zinging here and zinging there and zinging here. It's like airplanes in the sky. It's really hard to get them to interact with each other. Yeah, there's some if we have plane crashes every once in a while because planes get too close to each other, but they're not very common. Not as common. Okay? All right, so here is some states of matter. This is solid SiO. This is sand. This is what sand looks like. If we heat sand up really high, we get glass. And with glass, it is arranged in a certain order. Liquid, they're tumbling over each other. Okay, so a solid, it's arranged in a specific way. Liquid, these tumble. Gases are far apart, but they're very, very fast. Okay, so existing as a gas, liquid, or solid depends on how much energy do I have and the strength of the interaction. So how strongly am I attracted or repelled by something? Okay? Those are my two important things. Kinetic energy is how much energy do I have stored inside me that I can use right now. Okay? If it's just stored, it's potential. But if I'm using it, it's kinetic. Okay? All right, so here we have an example of a possible problem. Okay, so here we want to calculate the volume of 125 grams of seawater, and the density is this. Okay, so the first thing, oh, I got it right. Didn't have it plugged in. Okay, so first thing I want to know is density is equal to mass divided by volume. So your little dance, if you're in love, if you forget which one goes on top, you hold your little heart up like this, and your mass goes on top.
Howell?
Yes?
Had Bree Spencer in class?
Yes? Yes?
Did you send her to the main office for a minute?
Okay. All right, so then we just plug in for what we have. We want volume right here, so I'm going to times both sides by volume. When I do that, volume goes off on this side and I get mass. Actually, I've not got mass. Never mind. I don't want. I want volume. So I'm just going to times both sides by volume. I do that anyway. Over here, volume's going to go out. Divide both sides by density. You can do it really fast, but mass is equal to density times volume. Plug in. So my density is 1.03 grams per milliliter. Timesing it by, this is not going to work. What did I do wrong?
You switched
I need
the
to
M and the
be,
B.
it needs to be, yeah. Sorry, I'm trying to go too fast. Slow it down. All right, slowing down. Density, I'm trying to find volume. Volume's coming on top. Mass divided by density. Okay, so we're going to take 125 grams divided by 1.03 grams per milliliter. By doing that, grams will go out and we'll end up with milliliters, flipping to the top. 1 over milliliter. Okay? So if somebody got a calculator, run that through. It should be just about 120 milliliters.
What is like
121 milliliters. Does it what?
Does that really there's like that simple thing of like M over D? Does that ever get like stoichiometry where there's multiple like steps you have to do?
No. When you're working with density, it's usually just mass over volume. That's what you call it. Okay, on this next one here, we've got a density at 20 degrees. We've got a density at 100 degrees. And we're supposed to calculate the change in volume that occurs when a 10-gram piece of copper is heated from 20 to 100 degrees. Okay? So if we look at this and we can take it out at the density, we can just calculate the volume at each temperature and then take the difference. And we've got the difference. So here, we're using 10 grams. We're using a density. We're finding volume for each of them. So at 20 degrees, see, I would have the volume is equal to the mass, 10.0 grams, divided by the density at that temperature. Centimeters cubed is just a milliliter. I would do it again at 100 degrees Celsius, where the volume is 10 grams, divided by 8.83 grams per centimeter cubed. Grams will go out. We'll get our answers. Let's get those answers. We'll have a calculator. It'd be just under 2, so 1 point something on both of them.
Thank you. Got like 0.011.
On the top one,
Oh no, wait, I'm sorry. Never mind.
it should be
I
1
was-
point something.
I've already done this. It's tired.
You got what? 1.12 centimeters cubed. What do we get for the second one?
1.1.2.
Okay, so the difference, and it's not going to be a lot, but the difference in volume is 0.01 centimeters cubed. It's not a lot, but metal does expand and contract a little bit if you heat it or cool it, right? And it's just enough that it won't fit or it will fit into a hole. So we can heat or cool it to get it where we want it to go. All right.
When we're doing density, we already do centimeters cubed.
Yes. Well, centimeters cubed and milliliter are the same.
Yeah.
So I could say 1 milliliter is equal to 1 centimeter cubed. Okay, I need you to mark on your thing because the bell should be ringing. need you to mark start here, because I don't want to start in kinetic theory until we can do it all at once. Because I'm going to give you easy ways to remember it. Hopefully it'll stick in your head. Okay? Alright, that means you guys should be working on Learn Smart for Chapter 7. Okay?
Chapter 6 where?
What?
I want that class.
31 is an count. On Monday, they're 30. Tuesday, they're 30. Yes.
Okay, so I submitted all my I'm really like a reason.
Look at it for a second, yes. Can I get all the thank you letters? Did everybody get a chance to sign one?
No.
You just write it.
Yeah, somebody needs to tell thank you, do something for me for both. Thank you. Please check your grades. If there's a problem, I'll be here tomorrow morning, but in the afternoon I got training session, so I won't be here in the afternoon. Okay? So if you have a problem or you need something, whatever. Please let me get a permission slip with your pictures up there. Go check the wall.
It's not. It's not.
There should be a
That'll be for the house next term.
Bring you
That's all personal. I'm gonna read over and then if I just say
My grade was on zero.
yours go even higher.
I might even bump a thing if you get the permission slip tomorrow. When you're on there. The same. I might add some points to it.
Oh, please, I need everything.
I need these permission slips in.
So, Wednesday,
Why don't you let these two be part of the video?
If you can tomorrow, I'll be there first. Because I have to get it in before the end.
tomorrow?
Yeah.
It is. How do I agree to you? Because I can't do it long.
Cassidy Christensen and Nicholas Saxon to the attendance office.
Thank you.
Alex, meet with this way.
If you're in it at all, I have a permission slip. Thank you.
On mine, you can literally, you just see this little spot and it's like, how does someone know?
Actually, I have to, if there's a person in there, I have to have a permission slip or I can't turn it in. Even if it's the back of your head.
My
Abigail Marcus to the attendance office.
Oh,
Abigail Marcus.
Thank you, sir. Yes.
What are we doing today?
We are watching the code. Talking the code of life.
I was
Any
just
questions on that? 'Cause that's what we
washing the
file. You want to take this and then?
Oh no, just because Bryn's not gonna be.
My DSP
Okay,
website.
well, take one for this.
Okay, because her
We're
schedule
gonna
from Layton
start
gets
it.
out later, so right as she'll be here like 20 minutes or less. So I'm just like, is it worth it for the time? Or
I
I'll tell her to
do have-
video, tell her
I have the
to
video. I have it online.
Okay.
So, I don't have it online, but it's, I've got it there, so you can watch it. I'll
You
let
just
her
need
know, yeah.
my signature on it then?
It should be parents.
I'm 18 though, so
Technically, she could.
technically speaking.
I just need permission.
Okay, I'll just have my mom sign it. Just to be safe.
Till 11:59 tonight, the last three.
Can I return that?
Yeah.
When do you need the permission slip?
What?
When do you need the permission slip?
Tomorrow if possible.
Tomorrow? Okay. I can bring it in tomorrow.
That would be awesome.
Or I can just bring it back down
We
in a
are
minute.
watching,